we're running a little bit late, so I've got the next talk, which means I got freedom to kind of accelerate it a little bit and kind of get us back on track. And I know most of you all anyway, so we do have a few things into here we haven't talked about too much before. But the short end of a long story is my name is Jason Held. I'm the CEO of Saber Astronautics. We've been around as a startup in Australia since 2008. Which most investors will kind of shake their finger at you, and it's been too long without investment, but we kind of bootstrapped and built up, and now we're at the point where we have really kind of built it from the garage ourselves into a product that's useful and sellable. That's what we're doing. Now, for those of you who we haven't met, we're a small business. We got 6 people here and 3 people in the US at the moment. But we pack a lot of technical punch. We've got people who worked on Hubble and the ISS. On the flight software side, we got PhD graduates from the Australian Centre for Field Robotics just down the road, and decorated officers from Army and Air Force Space Command. That last question was actually quite interesting because we have an internship program that we get about 150 applicants a year. We train them up and then send them off to NASA, to ESA. A few went off to Stanford, Planet Labs, etc. But if you think about the skill sets and the way it's laid out, it's very focused on software and operations and the interplay between those two fields. So it brings us to the problem that we formed to solve. Right? This right here is the problem. Mission operations, flight software. It's very bespoke. It's very messy. The flight software that you have to control spacecraft is about 10 to 15 years behind the rest of the world. I mean, if you're looking at screens like this, you've got all these different things you have to do to run a mission. You need dish controllers, you need operations planners and Gantt charts, you need health and welfare, so you want to know how healthy the satellite is. So you've got all these people that are going to run all these different screens to keep different parts of the space mission alive. And it's really important because every minute of satellite downtime is millions of dollars lost to your downstream customers. So if you're launching a satellite, then you have to learn how to put all of this together into one big happy bundle and do it in a way which is quite easy. It's kind of like the state of the industry is kind of like this. You have to learn how to knead your own bread every time you've got to make a sandwich. All right? That's literally what you see out there. So a lot of you doing PongSats, CubeSats, etc. I see a lot of teams, even teams that get funding. They say they got this kind of, I want to be a Jedi like my father thing and prove that they could do every single one of these steps all by themselves. And what that does is that adds risk to the project. Okay, so you got to do all that to make a satellite mission, and we said, all right, well maybe there's a better way for us doing software. So we're solving this, and you think in terms of complexity, both on what you see on the screen and what's happening behind the scenes. Okay, if there's something wrong with the spacecraft, then it takes a team of people to say, here's what's wrong, and get it back operating. And then there's the front side of it, the graphical side, where instead of looking like the Matrix, we want it to look something like this. So this is the first thing that we have. We have a product called the Predictive Ground Station Project. Affectionately, we call it PIGGY, which we believe is going to be the next generation of satellite control. So, and I'll get a video I'll show you in a bit, but we just took a few of these different tasks and said, all right, what would have happened if we took situational awareness, knowing where your assets are, and we took dish controller and some real basic alert system, and we married that together into one product. And we started flying in 2014 with a customer out of California, these guys called SkyQ, who are doing education satellites. Really cool project. You can buy minutes of time on the spacecraft for your kids. So it's like, here's 20 bucks, I get 5 minutes of time in the spacecraft, Best Dad of the Year award, and it's pretty awesome. But the whole point was, because we just added those 3 components together, situational awareness, dish control, alert system, we could rapidly iterate the operations and the command for the spacecraft to the point where the other operations center, we were beating the entire network, happened to be the United States Navy's small satellite network called the MC3, by a factor of 2, just with our own little lab. So you see kind of this trend with missions, and a lot of these companies like Fleet Space is going to do 100 satellites. Myriota is also going to do a large number of satellites. A bunch of other companies outside of Australia, I don't want to mention because they're outside of Australia, And they're all kind of following that same trend. You know, I will mention OneWeb because they're fascinating, 4,000 satellites. And I ask, how are you going to do that? You know, it's a big mission. How are you going to do that? How are you going to have 4,000 satellites managed by a small team of people and do that in a costly fashion? And the answer for a lot of them, not all of them, but a lot of them has said, well, we don't care if the satellite lives or dies. That's the Planet Labs answer. If the satellite dies, we'll just launch another one, which is only true until their investment running runs out and they actually have to get customers, right? And then they want to keep their birds alive. Okay, so again, we've been doing this for a few years now. We've got the product up and running. I'll show you a video demo in a minute, but you know, getting some customers on the door, under the door. Google, Braxton, a couple of big names here. Fleet Space, I love you guys. I just want to give a big hug. You kept us alive last year. And also a bunch of universities. So we've got a mix of the product that you can buy if you're an undergraduate student or a PhD student. It only costs $15 a month to get real basic services. And actually now is probably a good time to show the video. Yeah, you don't want to see my grant proposals as I write them. Of what we did for Fleet, very interesting use case where you're trying to track the health of a large constellation of 100 satellites tracking Internet of Things. Their problem was they needed investment. Okay, so they needed to prove that their mission would work. They also needed to submit an initial application to the ITU, which requires evidence that it's going to work. So what we did was we set up the operations with the constellation, and we optimized it using Monte Carlo methods with 2 undergraduate students, and it took 2 months of time to come up with an optimized mission plan for them, the fidelity needed, not just to get the ITU application complete, but also to connect the dots between the mission and the overpass you're getting over the ground station, and how much data you could pipe in, which directly equates to the amount of customers that Fleet was able to prove, which they then handed to their investors. Here's the size of our addressable market. It's a very large number, and that's why, one of the reasons why they were able to raise the investment that they had. So we're looking to recreate that model with other startups here in Australia. All right, that's enough of that. All right, so on the back end is machine learning. So it's the question, if you have something wrong with the spacecraft, how do you tell what that wrong is? Well, it's a computationally complex problem. So literally super exponential to the number of sensors on the spacecraft, which means you're going to have an infinite number of combinations if something goes wrong. And the operator's job is to keep that satellite alive. So what we did was we created a special machine learning tool that took inputs from all these data feeds. So the Space Weather Protection Center from Boulder, Colorado, everything happening inside the satellite, everything happening in your space environment, and we're able to tell you full cause and effect analysis for the satellite. So just to illustrate, the slide on the left is a solar flare that happened, and we wanted to know how much damage it has in the spacecraft, and can you prove it? Well, based on the damage that was in the spacecraft from the solar flare, we were able to recreate that signal almost exactly, which means you, as the operator, have very high confidence that here's what you have to fix to keep that satellite alive. All right, and we said, okay, if it works on the ground, can it also work in space? So under a NASA small business grant out of our lab in Colorado, we're able to prove that on a subsystem. You could track, space radiation, electron and proton densities, and we're not at the point of repairing things yet, but we're just at the point of saying, here's what the problem is. Now you got to add in the autonomy to change your state to fix the problem. So off the back of that research, we have a space flight that on the ISS, the back portion of the ISS, to prove that. Now we're also trying to see, all right, if you could keep your avionics alive, can you use this for other subsystems like GPS, which can reconfigure itself in the face of unintentional jamming, or maybe optics that can recreate at the pixel level, recover from damaged pixels. So very, very highly useful to the types of customers you guys would have. All right, so I'm going to skip that. It's a bit academic. So that's really it. That's the program in a nutshell, and I'll probably end it here and give myself time for one or two questions if you have any. Otherwise, we can move on.
How much do you think an example of you helping Flight and Flight helping you is a model for the rest of the industry in Australia?
That's a great question. I like the idea of Australian companies buying and selling from Australian companies. Because Fleet, at the end of the day, could have started up and said, you know what, we're going to call Boeing, Lockheed, Northrop. It would have been, because of the way we designed the software, it would have taken at least 6 months to 2 years. It's about the time it takes other organizations to get the same result. And it would have been a time and materials contract like us, but it would have taken longer and more expensive. So from our perspective, we like it. I think Fleet's happy with it because it worked out well for them. But in general, look at all the people in this room. I want all of us to be working together. I am tired of seeing foreign companies coming in and taking our market share. And that $3 to $5 billion a year that Tim Parsons talked about, people talk about that's the size of the Australian space industry. That's the size of our expenditure. Okay, so the reason why a lot of that money goes from overseas is because we as a small business community need to get our products up to snuff enough that we can compete against older, more established players. Okay? Is that it? In the back.
You don't have to answer this. What is your funding stream, both in the US and here?
We are, yes, that's the, we bootstrapped. So we raised, over the history of our company, about $800,000 in grants.
That's SBIR or something?
Say again?
SBIR.
SBIR was only a quarter of that. Sorry, less. SBIR was about 110 of that. All right. The cases grant we haven't spent yet. It's about 200,000. So I guess historically you're looking at about 600,000, $500,000 in Australia, the rest in the States. Not enough to keep a company our size alive that long. So customers like Fleet Space was quite good for us last year. We had, if you could diagnose the health of a satellite, you can do a whole bunch of other things like water utilities. We helped out a startup hedge fund in Melbourne, a GPS tracking company in Sydney. You do these kind of gap filler projects. The earliest days that you guys first heard of us, we made a beer you could drink in space and partnered with a Four Pines brewery, and it now sells in 580 stores around Australia. I don't mention it normally because people forget about everything else I've ever done. I mentioned that, but that's just, it's like our startup story. In 2008, nobody was investing in space except for Silicon Valley. A few investors were doing it, and out here in Australia, we talked to a few investors, and even the ones that were kind of leaning in was like, I don't really care about space. I don't want to know about that stuff. Just tell me about the green, baby. Tell me about the green. And I kind of backed away from that because it's kind of a confronting thing. If you're an entrepreneur, you don't really trust an investor who says that to you. So it's more of a sign that right now the market's changing in the favor of, I think, everyone in this room. So, okay, probably enough. I want to save some room for lunch and 2 more talks we got to do. Keith